The world of strategic deterrence entered a new, uncertain chapter just a few weeks ago. In a dramatic display of air power on June 21 and 22, 2025, the United States Air Force executed Operation Midnight Hammer. The mission's objective was clear: to neutralize Iran's hardened nuclear facilities using the most powerful conventional Earth-penetrating weapon ever built, the GBU-57 Massive Ordnance Penetrator, or MOP. B-2 Spirit stealth bombers flying under the cover of darkness precisely delivered 14 of these colossal 30,000-pound bombs. The primary targets were the deeply buried Fordo and Natanz enrichment complexes, sites that have long been a focus of international concern due to their fortified nature and central role in Iran's nuclear ambitions. The operation was a textbook example of precision bombing. Satellite imagery confirmed that the massive weapons struck their intended aim points with incredible accuracy. At the Fordow facility, which is notoriously dug into a mountain, 12 MOPs were concentrated on just 2 impact points, with 6 bombs sequentially slamming into each spot to maximize their burrowing effect. This tactic, known as a bunker buster train, is designed to have each subsequent bomb dig deeper than the last, creating a devastating path toward the target's core. The sheer kinetic energy released was immense, intended to shatter meters of reinforced concrete and earth to reach the critical infrastructure hidden far below the surface. Despite the flawless execution and the confirmed direct hits, a troubling reality soon emerged from the post-strike analysis. While the Pentagon officially stated the raid had set back Iran's nuclear program by 1 to 2 years, independent analysts and even some intelligence assessments painted a more complex picture. It is believed that the most critical chambers within the Fordo complex, buried approximately 30 meters deeper than the MOP's estimated 60-meter penetration capability, may have survived the onslaught. The MOP, for all its immense power, had seemingly met a challenge it could not overcome. The operation inadvertently highlighted a critical vulnerability in the U.S. arsenal. The aftermath of Operation Midnight Hammer served as a stark and urgent wake-up call for military planners. The mission proved that even the most powerful weapon in the inventory has its limits, especially as potential adversaries continue to dig deeper and build stronger fortifications. The International Atomic Energy Agency suggested that enrichment activities, though disrupted, could potentially resume within months, not years. This sobering assessment has accelerated a program that was already underway, forcing the Air Force to confront the fact that to hold future deeply buried targets at risk, it needed something far more advanced than the mighty, but ultimately limited, Massive Ordnance Penetrator. The age of the Next Generation Penetrator had officially begun. In response to the lessons learned from Operation Midnight Hammer, the U.S. Air Force is now fast-tracking the development of a successor weapon, the Next Generation Penetrator, or NGP. This new munition is not merely an upgrade to the old GBU-57 MOP, it represents a complete rethinking of how to defeat the world's most hardened and deeply buried targets. The fundamental design philosophy behind the NGP is to replace the MOP's brute force approach with a combination of advanced technology, superior intelligence, and enhanced flexibility. The program aims to create a weapon that is smarter, more versatile, and ultimately more lethal against the underground fortresses being built by potential adversaries around the globe. One of the most significant improvements planned for the NGP is its size and weight. While the warhead itself may weigh up to 22,000 pounds, the overall munition is being designed to be smaller and lighter than the 30,000-pound MOP. This change is critical for its integration with the Air Force's new B-21 Raider stealth bomber, which has a smaller payload bay than the B-2 Spirit. Furthermore, unlike the MOP, which is a simple gravity bomb, the NGP is expected to feature a powered standoff capability. This means it could have a rocket motor or small jet engine, allowing the launch aircraft to release it from much safer distances, well outside the range of enemy air defenses. The NGP will also feature a revolutionary leap in accuracy and guidance. The weapon is required to achieve a terminal accuracy of CE-90 within 2.2 meters, which means that 90% of the bombs must strike within that tiny radius of the target. This level of precision is crucial for ensuring that the warhead's energy is focused exactly where it needs to be to breach complex underground structures. To achieve this, the NGP will incorporate highly advanced autonomous guidance, navigation, and control systems that are resilient to jamming and can operate effectively even in GPS-denied environments, a growing concern in modern warfare. Perhaps the most game-changing aspect of the NGP lies in its intelligent fusing technology. The munition will be equipped with sophisticated embedded fuses, including void sensing and floor counting capabilities. This allows the bomb to autonomously detect when it has passed through layers of concrete, earth, or empty spaces within a bunker. It can then detonate at the most optimal point inside the facility, for example in a specific command center or storage chamber, even if intelligence about the target's exact layout is incomplete. This smart fuse technology ensures the weapon's destructive power is not wasted and dramatically increases its probability of mission success against complex, multi-level underground targets. The development of the Next Generation Penetrator is intrinsically linked to the deployment of the Air Force's new B-21 Raider stealth bomber. This pairing is not a coincidence. It is the core of a strategic vision for maintaining U.S. air dominance for decades to come. The B-21 is being designed to penetrate the most sophisticated and heavily defended airspaces on the planet, places where older aircraft like the B-2 Spirit would face unacceptable risks. To make these perilous missions worthwhile, the Raider needs a weapon capable of destroying the high-value, deeply protected targets that would warrant such a sortie in the first place. The NGP is that weapon, the spear specifically forged for the Raider. The synergy between the B-21 and the NGP will redefine long-range strike capabilities. The B-21's advanced stealth characteristics will allow it to get close enough to enemy territory to launch the NGP, while the NGP's own standoff capability will allow the Raider to remain outside the most dangerous threat rings surrounding a target. The NGP's smaller size, compared to the GBU-57 MOP, is a critical design consideration that allows it to fit inside the B-21's payload bay, a feat the massive MOP might not be able to achieve without significant modification or compromise. This integration ensures that the Air Force's newest bomber will have a bunker-busting tool from day one of its operational service. This potent combination of a survivable delivery platform and a highly advanced munition provides military commanders with credible conventional options for addressing threats that might otherwise require a nuclear response. The ability to hold an adversary's leadership, command and control centers, and weapons of mass destruction facilities at risk, no matter how deeply they are buried, is a cornerstone of modern deterrence. The B-21 and NGP pairing sends a clear message to potential foes: there is no place to hide. This capability is essential for de-escalating potential conflicts and providing the president with a range of powerful, yet non-nuclear options during a crisis. The strategic importance of this pairing cannot be overstated. As nations like China and Russia continue to invest heavily in integrated air defense systems, the ability to project power becomes increasingly challenging. The B-21 Raider armed with the NGP is the tip of the spear for the U.S. military's response to this challenge. It ensures that even the most fortified assets, located deep within contested territory, are not immune to attack. This forward-looking approach, where the platform and the weapon are developed in concert, is a testament to the comprehensive planning required to maintain a strategic edge in the complex security environment of the 21st century. The accelerated push for the Next Generation Penetrator is a direct reaction to a clear and growing global trend. The world is going underground. From China to Iran to North Korea, potential U.S. adversaries are increasingly moving their most critical military assets into deeply buried and hardened facilities. These subterranean complexes are designed to protect leadership, command centers, missile arsenals, and weapons development programs from conventional airstrikes. As revealed by a 2024 RAND report and satellite intelligence, China has constructed vast underground military compounds and hundreds of hardened missile silos designed to withstand anything short of a direct nuclear strike, presenting a monumental challenge to U.S. military planners. This global bunker-building race fundamentally changes the calculus of modern warfare. The effectiveness of an air force is no longer measured simply by the number of aircraft it possesses, but by its ability to neutralize these protected targets. An adversary who believes their leadership and retaliatory capabilities are safe from attack is more likely to be aggressive on the world stage. Therefore, possessing a credible conventional weapon that can defeat these underground sanctuaries is a vital component of strategic deterrence. The NGP is designed to be that credible threat, ensuring that no target is beyond reach and thereby discouraging potential conflicts from ever starting. The lessons from Operation Midnight Hammer underscore the critical importance of technological superiority and precision. The GBU-57 MOP, a marvel of engineering in its time, was ultimately defeated not by enemy action, but by the sheer depth and strength of modern fortifications. This illustrates that simply having a big bomb is not enough. Future success depends on the integration of advanced technologies, smarter guidance systems that resist jamming, autonomous fuses that can outthink defensive designs, and powered munitions that provide flexibility and safety for the launch platform. The NGP embodies this shift from brute force to smart, precise power. Ultimately, the development of the Next Generation Penetrator is about maintaining a credible deterrent in a rapidly evolving security landscape. By pairing this advanced weapon with the B-21 Raider, the U.S. Air Force is ensuring it can hold any target at risk, anywhere in the world, without having to resort to the use of nuclear weapons. This capability is the bedrock of strategic stability, providing a powerful tool to shape adversary behavior and protect U.S. interests. In the silent underground arms race of the 21st century, precision, technology, and foresight are the keys to victory, making the NGP one of the most important defense programs of our time.